Good morning, ladies and gentlemen. It was a very good digital presentation from Terry. We'll probably prove a few questions, but I'll take maybe a minute to introduce both Terry and Graham. On my left side, Graham has been appointed CEO of Australia Vanadium Limited in 2022. He held some key leadership position in IGO, Primary Group, and Pilbara Minerals. Graham has experience both in energy and metal background, with production manager in Midwest Vanadium and energy management in Epcot Energy, a leading Canadian retailer. His both experience in energy and resources sector is a great asset for the AVL's mining to battery strategy. Terry has a very long 37 years of experience in vanadium industry, started with US Steel, 2 decades in Stratcore, which was taken over by Evrad. He set up TTP Square in 2010, and then he later on joined Atlantic Limited executive team and founded US Vanadium, which in turn acquired assets of Evrad. So really long experience in vanadium industry. Probably I will start with a question which you dealt it a little bit in the beginning of your presentation. Means vanadium flow battery has been there for almost 40 years, and it's been connected with the grid even for like 20 years. Why we are seeing such kind of excitement in vanadium flow battery, particularly in China, and what it means going forward, both for China and as well as for the world?
Yeah, so I think there's really 2 factors that are driving the inflection point in the demand for vanadium in these batteries right now. One is the maturation of the supply chain. As I said, we've seen the first gigafactory now in production in China. And when we look at capital costs, there's tremendous opportunities for the cost to come down. The battery people, by and large, will tell us that they're in a position where over the next couple of years, capital costs for the system, the hardware side of the system can drop by as much as 70%. So we're seeing the maturation of the supply chain along with the development of really a new market. That new market is long duration storage at grid level. And again, when we get to the point like we have in Southern California, where more than 50% of the supply of electricity comes from renewable but intermittent sources, we have serious stability problems. We need to find a way to take that power that we can produce in the middle of the day or when the wind's blowing and deliver it to the late afternoon when the peak demand shows up. And we're talking about many, many hours of duration. We're also looking at opportunities now for seasonal load shifting, producing a lot of solar power in the winter or in the summer and delivering it back to the grid in the winter. And this is a perfect application for vanadium batteries. Great thing about these batteries are they don't fade. There's no loss of capacity over 30,000 cycles. Essentially, the vanadium can be cycled an infinite number of times. You hear people talk about vanadium being expensive, but if you think about cycling it an infinite number of times, and we look at the levelized cost of storage, the cost of the vanadium per cycle approaches 0. So as we go forward here, we're seeing really the confluence of those 2 issues, the supply chain maturing and the long duration grid level storage market taking off.
I think just the related question is going to be how it compares with lithium phosphate battery as well as nickel battery. And I think invariably that comparison will come in terms of scalability, cost, and safety. So whoever wants to go first.
I'll jump in there. We spend a lot of our time working on what are the economics of the battery against lithium ion phosphate applications. That is the dominant use case in battery energy storage right now. The reality is that works up until about 4 hours, and it may work up until 10 hours. There's a crossover point where vanadium flow batteries become very attractive on a levelized cost of storage basis, and that's how the industry thinks about these batteries. At about 4 hours, you become very competitive, and then ultimately the other merits of the battery then stand at the front, which is that you can augment duration. And so if you're a battery developer, you're often thinking about how do I expose myself to the maximum number of revenue stacks in any application. And the more we work with end users on the energy side, that's turning out to be a really critical asset of the vanadium flow battery. It can do everything a lithium-ion battery can do, but in year 3 or 4, if the market goes to 8 hours or 10 hours or 12 hours, you can actually respond to the pricing mechanisms and build your financial models around that. The ability to augment at later points in time with lithium-ion is really not possible, or very difficult at best and expensive. With vanadium flow batteries, very cost effectively, you can simply add additional electrolyte in tanks and augment to longer duration, and that, if you're running economic models in a BESS application, is pretty powerful. And then you layer on top of that, in particular, the location of Australia, using as an example, you will see procurement teams for BESS operations looking at local content as a factor. So if you stack up on cost, with lithium-ion, you're probably going to struggle to get even 20% local content if you try hard. With vanadium flow batteries, you'll, without even getting out of bed, end up with above 70% local content. So if you can stack up the economics, you then have a non-flammable product that has high local content, is augmentable to match the market in the future. And the more we work with end users and big gen tailors in Australia, the more they realize the levelized cost is competitive, and the more they look at the other options that are available once you install a flow battery, and they get very excited. And to Terry's point, the scale's already there. Rocket Power, as an example, is just deploying them at incredible scale. And there's over 100 other flow battery manufacturers in China and a bunch of international manufacturers who are scaling up as we speak. It's very exciting.
Anything you want to add?
I'll just add that last week I also had the chance to visit what was, until a few months ago, the largest vanadium flow battery deployed in the world. This is a 800 megawatt hour system in downtown Dalian, in the center of the city. And the use cases here are black start, emergency power backup, load shifting. It's been operating for 8 years. It's in an environment where there's an issue with grid power. They're in a position to instantly jump in and restore the grid. You need to have that sort of storage near the load, and that's a place that's impossible to put a lithium battery at this scale. So, the other factor here, I think, is you look at the whole safety issue.
Yeah, I think it's very interesting because even Singapore is looking at in deploying vanadium flow battery. One of the things is Singapore is land constrained, so putting underground, and you can put a large battery, and safety is definitely paramount. So that's why vanadium flow batteries stacks up quite well.
And I think in the next couple of months, you're going to see some announcements of some very large-scale vanadium flow batteries in conjunction with data centers, again, underground, where we can't put a lithium system with building and people on top of it. So there's numerous use cases where these systems are really cost effective today.
Understand. You touched upon a little bit of demand supply. So question is actually both of you. What's the long-term demand supply for vanadium? And secondly, what's the kind of benefit of having integrated operations like AVL has got, and the difficulty in terms of processing vanadium ores versus lithium? So question both of you.
Maybe I'll go first. And I would like to comment that perhaps something to think about is not even the long-term, but the short-term situation with vanadium supply. By way of example, Terry just quoted an 800 megawatt hour flow battery, which is currently the largest in the world. We're actually seeing, for the first time outside of China now, a 500 megawatt hour battery that is now slated to be built in Western Australia. So not far off the largest in the world, going to be built soon in Western Australia. And to the point of vanadium supply, that battery is almost 2% of the world's vanadium supply. And even in the current, what would be called slightly oversupply situation in vanadium, if you go out on the market right now and try and procure oxides, it actually becomes a supply issue relatively quickly for one single battery. And at Australian Vanadium, we're looking at 4 or 5 battery options on the east coast of Australia that are all significantly larger than that. So it doesn't take much, even in the short term, to get that adoption rate continuing even on its current pace in China, which is set to accelerate significantly in the very near future. If you layer on that other jurisdictions like Australia, where the renewables penetration is already significantly higher, and there are market mechanisms for 8-hour batteries plus, data centers that are asking for 16-hour batteries, people like Rio Tinto wanting 48-hour batteries, it's, for me, a very near-term vanadium supply issue. And then there's a longer-term piece, which I'm sure Terry can comment on.
Yeah, if you look at the supply base for vanadium, about 70% of the supply is really a byproduct from steel mills in China and one mill in Russia. And we know what the situation with steel production in China is right now. So we're not going to see any growth in supply from those sources. It's probably going to be the opposite given the situation here. And again, we've seen the data on the supply side, even with the most modest forecast for growth in vanadium flow battery demand. We're going to be in a position where, this cycle of overproductions, really this year, if you look at the numbers in the presentation, we expect to see a very balanced market this year. We have built up some inventory over the last couple of years, but clearly by the time we get into, sometime next year, that excess inventory is going to be gone, and then, we're going to go through the cycle again. And I can taste it, I can smell it, it's right there.
Yeah, I could see that your price chart, like 80% probably down from its peak in a couple of years back. So probably hitting bottom. I think one thing which probably, Graham, you can talk about means you yourself is setting up the 50 megawatt battery, right, downstream. And what's the advantage of running an integrated operations like AVL from mining all the way to the battery, and the challenges as well in terms of processing ore like vanadium?
So right now, the challenge is about doing what they already do in China, and that is, if there's all the large energy sector players that we talk to in Australia, it's no longer a question of is there technical risk, which is the key benefit of flow batteries. The technical risk is gone based on what China's doing. You can go to the facility that Terry was at last week and you'll be a believer. And you can go to Ronki Power's fully automated factory and see the cost base coming down and where the future is going to be. So it's just, can you actually deliver this in Australia? The way we've addressed that is by literally fully designing and costing a 500 megawatt hour battery using local contractors for construction design, proven battery suppliers, and being ready to deliver. So what's missing outside of China is that off-the-shelf solution, which is what we're doing. So that's the downstream side of our supply chain, which we're most excited about, because at current vanadium prices, there's a very, very compelling battery sector levelized cost of storage. We've put in all our modeling realistic pricing. To Terry's point, the long-term average price of vanadium is $10 to $12. Even if you put that in a battery model, it's still very compelling for all these long duration applications. So then for us, the challenge is, how do you link up a supply chain? And it does come down to vanadium. If you look at these batteries, they are very simple. They're tanks, pumps, piping, and vanadium. And if there's a way to deliver the supply chain, is simply by making lots of vanadium oxides at high quality and the lowest quartile price. And that's what we're setting out to do in Western Australia. And we've established electrolyte manufacturing there already. And I think for me, in the Australian context, there's no other battery supply chain you can do that. You can literally cost effectively, with structural cost advantage, make electrolyte locally. Yeah, we've done it.
Tony, we have 2 minutes. Anything you want to add? Probably one final question is that lithium is very popular in the mobile applications. Do you see at any point of time vanadium can probably start competing on lithium on mobile, or it will be always the static operations?
Well, what we're seeing now is people putting lithium in various batteries that are for mobility. Right now, this technology, vanadium flow battery, the only mobility application is seagoing vessels. That's a very interesting model. We can talk about that later if somebody's interested. But primarily, we're looking at vanadium now going into both cathodes and anodes of lithium-ion batteries. And the purpose of this is to really address the two major shortcomings of lithium-ion batteries right now. One is the energy density, basically doubling energy density, which means I can drive twice as far before I need to recharge, and dramatically decreasing the recharging time. We're talking about 5 to 8 minutes to recharge a battery instead of an hour or an hour and a half. So there's some really exciting things out there. Those are still a bit down the road, but there's some really, really exciting things. Vanadium is a very interesting element. It's stable in 4 states of oxidation. It makes it usable in many electrochemical applications.
So effectively what you are saying is that vanadium can move even from the static to mobile applications, and probably can as a complement to the lithium-ion battery rather than just the competing.
Exactly.
We are almost like very close to that. We have got 18 seconds left, so we finished before the timing. Thank you very much, Graham, and thank you, Terry, for having this interesting discussion. Thank you very much.
Thank you.
Thanks.
Thank you.
Thank you.